Ever thought about what happens to the trigonometric formulas we memorized just to pass math? What if I told you they weren't worthless at all? They're used in our daily lives, and we don't even know it. 1. Socha to wa, the formula behind everything. Let's start with the Holy Trinity. Sin theta equals opposite over hypotenuse. Cos theta equals adjacent over hypotenuse. Tan theta equals opposite over adjacent. In class, these feel random. In real life, these formulas literally run the planet. Real-life use, GPS and Google Maps. Imagine you're lost. Your phone finds your exact position by measuring angles between satellites and Earth. How? By using sine, cosine, and tangent to calculate distances you cannot see. Just like that. SOHCAHTOA pinpoints you on the globe. Next time map says turn left in 200 meters. Remember, your phone is secretly solving triangles thousands of times per second. Other insane uses of Socha to wa. Snipers calculating bullet drop, tangent theta. Architects finding building heights. Robots detecting object distance. Game engines calculating character movement. The world runs on Sokotoa, but we're just warming up. 2. Pythagorean theorem, the formula that built modern cities. A squared plus b squared equals c squared. A formula so iconic it's basically the Beyoncé of mathematics. Real-life use, laser distance measurement. When a laser hits an object and you know two sides of the triangle, you calculate the missing distance using a squared plus b squared equals c squared. Surveyors, architects, builders, every one of them uses it. Now imagine constructing a skyscraper and getting the length wrong by even 1%. The building could literally tilt. Pythagoras doesn't let that happen. How your phone measures your steps. Yes, really. Step counters use small triangles formed by your hip motion. Pythagoras calculates the distance you walk. You thought you were just walking? Nope. You were doing trigonometry with every step. 3. The angle sum formulas used by pilots in turbulence. Sin A plus B, sin A minus B. Cosine of A plus B. Cosine of A minus B. Most students hate these formulas, but here's why they matter. Real-life use, airplane flight paths. When a pilot turns the plane and climbs at the same time, they are changing two angles simultaneously. To calculate safe altitude change, airplanes use angle sum formulas thousands of times during every flight. If these formulas didn't exist, your plane would unexpectedly meet the ground. We don't want that. 4th, law of sines, the formula that saves ships from crashing. A over sine A equals B over sine B equals C over sine C. This formula tells you exactly how big something is, even if you're far away and can only measure the angles. Real-life use, Navy ships avoiding collisions. When two ships are miles apart at sea, they can't measure the distance directly. So what do? They measure angles between their ship, the target ship, and the horizon, then use law of sines to calculate distance and avoid collision. Without this formula, the ocean would be chaos. 5. Law of cosines, the formula NASA uses for space navigation. C squared equals a squared plus b squared minus 2, AB cosine C. If Pythagoras had a big brother, it would be this formula. Law of cosines is for triangles where angles are not 90 degrees. Real-life use, navigating spacecraft. When NASA sends a spacecraft slingshotting around planets, they need to know exact distances and angles between celestial bodies. Because space is not made of perfect right angles, so they use planet A, planet B, the spacecraft, and the angle formed. Then law of cosines gives the exact distance needed to adjust trajectory. One wrong calculation, and instead of landing on Mars, your spacecraft might end up on Jupiter. Or worse, nowhere. 6. Graphs of sin, cos, tan, the formula behind waves, heartbeats, and electricity. You know those squiggly wave graphs? Yep, those. They are literally the heartbeat of physics. Real-life use, ECG machines, heart monitors. When a doctor checks your heartbeat, the graph they see is modeled using sinusoidal functions. Your heart literally beats in a sine curve. Electricity also runs on sine waves. Alternating current, AC, follows a sin wave. Every light in your house, every fridge, every TV is operating on trigonometry. Trigonometry is the reason your home isn't dark right now. 7. Inverse trigonometric functions, used in self-driving cars. Sine to the power of -1, cosine to the power of -1, tangent to the power of -1. These functions take ratios and turn them into angles. Real-life use. LiDAR in Tesla and self-driving cars. LiDAR sends thousands of laser pulses around the car. The computer receives distances and calculates. At what angle is the object? How fast is it moving? Will the car collide? Inverse trig functions convert raw data into meaningful angles. Without inverse trig, your self-driving car would be a self-crashing car. 8. Height and distance formulas used by movie directors for perfect shots. Whenever you see a beautiful drone shot, a dramatic pan, or a perfect cinematic angle, chances are the director used tan theta equals height by distance, sine theta for angle measurement. Real-life use. Film creation. To frame the perfect shot, they calculate how high the drone should fly, at what angle to tilt the camera, how far the subject should stand. You thought math was only for engineers? Nope, even movie directors are doing it. 9. Harmonic motion. How buildings survive earthquakes. Sin and cos are used to calculate oscillations, how things vibrate and sway. Real-life use. Earthquake engineering. Engineers design skyscrapers to move safely in earthquakes by modeling the vibrations using trigonometric wave equations. These calculations decide if a building stays standing or collapses. Trigonometry saves lives. Literally. 10. The final formula nobody talks about. Fourier series. Okay, this one is next level, but it's everywhere. Fourier series says any sound, any image, any signal can be broken into sine and cosine waves. Yes, everything you hear, see, or stream online is basically made of trigonometry. Real-life use. Music, cameras, internet, your favorite songs, movie audio, images stabilization, Wi-Fi signals. All are mathematically converted into sine and cosine waves. Your phone camera doesn't just take pictures. It calculates angles in real time. When your hand shakes, gyroscopes detect tiny angular movements. Using sine and cosine, the camera shifts lenses, adjusts pixels, stabilizes images. That's why your photos aren't blurry. No trigonometry equals shaky, unusable photos. So the next time someone says, "Where will you use trigonometry in real life?" just say, literally everywhere. You started this video thinking, trigonometry is useless. But now, you know it's the secret engine behind flights that stay in the air, skyscrapers that don't fall, GPS that guides your life, electricity that powers your world, doctors that save your heart, and spacecraft that explore the universe. Your entire reality runs on triangles, and the formulas you once hated are the formulas keeping your life together. So the next time you see sine theta, cosine theta, tangent of theta, a squared plus b squared equals c squared, law of sines, law of cosines. Just remember, you're not solving triangles, you're solving the universe. So how many of these places did you realize? We're using trigonometry every single day? Did any of them surprise you? Tell me in the comments. I'm genuinely curious. And if this video changed the way you look at math, hit the like button. If you want more breakdowns like this, where boring school topics turn into real-life superpowers, press subscribe. And I'll see you in the next one.